Welcome to another episode of Tiny Talks Big Ideas podcast. I'm your host, and today we're setting our sights on a world that truly redefines beauty in our solar system, Saturn. Just picture it. A colossal golden orb adorned with these shimmering rings, so vast, so luminous, they almost look painted onto the sky. It's an astronomical marvel that doesn't just catch the eye, it really captures the imagination. For anyone who's ever looked up and wondered what secrets are out there, our mission today, a deep dive into Saturn, its iconic rings, and its incredible family of moons. We'll be unearthing some surprising facts and crucial insights from recent observations and research. So let's jump right into this colossal gas giant, Saturn. It's kind of an anomaly right from the start, isn't it?
It really is.
Sixth planet from the sun, second largest gas giant, only Jupiter is bigger.
Right.
Its diameter is immense, like you could line up 9 Earths across it, about 120,000 kilometers.
Mhm.
But here's the really mind-bending part. Despite being enormous, it's mostly hydrogen and helium,
Just like the sun, yeah.
which makes it so incredibly light. Its average density is actually less than water.
It is. It's about 0.687 grams per cubic centimeter.
So if you could find a big enough bathtub,
Theoretically, yes, it would float. Though, keep in mind its total mass is still huge, over 95 times Earth's mass.
right, and that distinctive look, that golden color.
That pale yellow hue we see, that comes from ammonia crystals high up in its atmosphere. And if you could peek inside, scientists think there's a, well, relatively small rocky core, maybe similar to Earth's core in composition.
Okay.
But then surrounded by these incredible layers. First, a layer of metallic hydrogen, then liquid hydrogen and helium, and finally, the gaseous atmosphere we actually observe.
That internal structure sounds complex. What about the atmosphere itself? Anything particularly striking going on up there?
Oh, absolutely. You see bands like on Jupiter, but they're a bit fainter on Saturn.
Okay.
But the real showstopper is that bizarre hexagonal storm at the North Pole.
The hexagon, yes. I've seen pictures. It looks unreal.
It does. Voyager first spotted it. Cassini confirmed it and studied it up close. It's not just a storm. It's basically a six-sided jet stream, a totally unique weather pattern.
How big is it?
Each flight is about 14,500 kilometers long.
Wow, that's wider than Earth.
Exactly. And it's incredibly stable. It's been there for decades, maybe centuries. The dynamics keeping it going must be, well, pretty incredible.
And that's not all, is it? Didn't Cassini see something at the South Pole, too?
It did, a huge hurricane-like storm, about 8,000 kilometers across.
Like a hurricane on Earth.
Very much so, complete with a clearly defined eye wall. We haven't really seen that kind of structure on other planets besides Earth. Winds there are screaming at over 530 kilometers per hour.
A six-sided jet stream, a planetary hurricane. These are seriously alien weather systems. But of course, the main event for Saturn has to be the rings.
Undoubtedly.
They're the planet's signature, aren't they? Just
Yeah.
breathtaking, almost too perfect.
They really are the crown jewels, as people say. While Saturn itself is amazing, the rings are what make it iconic.
And they are huge, right? So
Well,
you mentioned way out.
Immense, over 280,000 kilometers across. But, and this is the kicker, they are incredibly thin.
How thin?
In some places, maybe only 10 meters thick. Think about that scale.
10 meters. That's like nothing compared to the width. Like a sheet of paper.
Exactly. It's hard to even visualize. As wide as the distance from Earth to the moon, roughly, but thinner than a tall building.
And they're not solid.
No, not at all. They're made up of billions, probably trillions, of individual particles.
Particles of what?
Mostly water ice. From tiny specks like dust up to chunks the size of mountains.
Mostly ice.
Predominantly water ice, yes. That's why they're so bright and reflective. Unlike, say, the darker rings around Uranus or Jupiter, which have more rock or dust.
So billions of icy bits, all orbiting Saturn, bumping into each other, sounds like chaos.
It's incredibly dynamic, yes, but maybe not as chaotic as you'd think. The main system has distinct rings. D, C, B, A, F, G, E, moving outwards. And there are gaps, like the famous Cassini division separating the A and B rings, discovered way back in 1675.
Right.
And these particles, they often have these sort of frosty, irregular surfaces. They collide, but remarkably gently.
Gently. How gently?
Velocities of millimeters per second, maybe up to centimeters per second. Really slow.
Huh.
And because the collisions are so slow and inelastic, they can actually stick together temporarily. We see evidence of what are called dynamical ephemeral bodies.
Ephemeral meaning.
Temporary, like house-sized clumps can form in just weeks,
Wow.
only to be broken apart again by other collisions. It's this constant cycle of building up and breaking down,
Yeah.
like cosmic rubble piles constantly reshaping themselves.
So the rings are always changing.
Constantly. And you also have these small shepherding moons like Prometheus and Pandora. Yeah, their gravity kind of corrals the ring particles, keeping the edges sharp or creating narrow rings like the F ring. They also carve out gaps. Pan, for instance, orbits within the NK gap in the A ring, keeping it clear. Daphnis does something similar in the Keeler gap, creating these visible waves.
So the moons are actually sculpting the rings.
Precisely. We even see disturbances called propellers, caused by moonlets too small to clear a whole gap, but big enough to stir things up locally.
Okay, let's get into the really tricky part. The age paradox.
Yes, the big mystery.
The rings look so bright, so pristine, but they're constantly being hit by meteoroids, right? Shouldn't that make them dirty, darker over time?
That's exactly the problem. Rings are basically giant nets, very efficient at collecting interplanetary dust and meteoroids. This incoming material, often darker carbonaceous stuff, should contaminate the bright ice.
So they should look older, grungier.
Over cosmic time, yes. Based on the measured influx of this darkening material, the brightness, or high albedo, especially the main A and B rings, suggests they are, geologically speaking, very young.
How young?
Maybe less than 100 million years old, which is, incredibly young compared to the solar system itself, which is about 4.5 billion years old.
Less than 100 million years. That's like yesterday, cosmically speaking.
Pretty much. And that's the paradox. This young appearance clashes dramatically with the leading ideas about how they might have actually formed.
Right, because the formation theories point to them being much older.
Some of them do, yes,
yeah.
Which creates this fundamental puzzle.
Okay, so how do scientists think they formed? What are the main theories?
Well, one classic idea is the condensation model. This suggests the rings are leftover bits from when Saturn itself formed, primordial debris that just never clumped together into a moon.
Leftovers from 4.5 billion years ago.
Exactly. The problem is, physics suggests that gas drag in the early solar nebulae should have caused that material to spiral into Saturn pretty quickly. It shouldn't still be there.
Okay.
And also, the composition doesn't quite fit. The rings are almost pure ice, very little rock. The original nebula should have had more rock mixed in.
So that theory has some issues. What else?
A more favorite idea is the destroyed satellite scenario.
Like a moon got too close and broke up.
Essentially, yes. The idea is that an icy moon, maybe 200 or 300 kilometers across, wandered inside Saturn's Roche limit.
The Roche limit being?
That distance from a planet where its tidal forces become stronger than the object's own gravity holding it together.
So Saturn's gravity just ripped it apart.
Pulled it apart, yes.
Yeah.
This fits the icy composition nicely and explains why there are small icy moons orbiting near the rings, maybe they're siblings or leftover fragments.
That sounds plausible, but are there catches?
There are. First, how does a big moon get into the Roche zone? They usually form further out. And second, tidal forces alone might stretch and break up a moon, but they wouldn't necessarily grind it down into the trillions of tiny particles we see today.
So you'd need something else, like a collision.
Probably. An impact could have shattered the moon after or while it was being tidally disrupted. Some link this to the late heavy bombardment.
That period early on when lots of asteroids were flying around.
Exactly. Around 3.8 or 3.9 billion years ago. An impact back then could have done the job. But that still makes the rings billions of years old.
Which brings us back to the paradox. They look young, but this theory makes them old.
Precisely. And again, where did the rock go? A moon that size should have had a rocky core, but the rings are very low on silicates.
Okay, any other ideas?
There's a third possibility. A tidally split comet or centaur.
Like Comet Shoemaker-Levy 9 at Jupiter.
Exactly like that. Imagine a large comet, maybe 300 kilometers wide, passing too close to Saturn and getting torn to shreds by its gravity. The debris forms the rings.
An icy body fits the composition.
It does. But the challenge here is timing and probability. The current number of large comets passing through the inner solar system seems too low for this to have happened recently.
So it would likely have happened long ago.
Probably during the late heavy bombardment again, when the flux was higher. But then you have to ask, why only Saturn, Jupiter, Uranus, Neptune also experienced impacts? Why don't they have massive bright rings like Saturn's?
Good point. So we're kind of stuck with this paradox then. Young looks, potentially ancient origins.
We are. It really highlights that there's something fundamental we're still missing about ring evolution. Maybe the B ring is much more massive than we estimate.
How would that help?
More mass means it takes longer for the incoming meteoroid dust to pollute it and darken it. So it could be older, but still look relatively bright.
I see.
Or perhaps different rings have different ages. Maybe the main A and B rings are old, but the F ring or parts of the A ring are younger, replenished somehow. Or maybe there's constant recycling of material within the rings that keeps them looking fresh.
Recycling, like the collisions breaking things apart and reforming them?
Exactly. Grinding surfaces clean, redistributing material.
Yeah.
It's complex. But the bottom line is the age of Saturn's rings is still one of the biggest unanswered questions about them.
Fascinating. Okay, moving beyond the rings, Saturn isn't alone out there. It has a huge family of moons.
An enormous family. Over 274 confirmed moons now, more than any other planet.
274.
And counting, probably. And among them, two stand out as incredibly interesting worlds in their own right. Titan and Enceladus.
Right, Titan and Enceladus. Let's start with Titan, Saturn's largest moon.
Largest for Saturn and second largest in the whole solar system, actually bigger than the planet Mercury.
Bigger than Mercury, wow.
And what makes Titan truly unique is its atmosphere. It's the only moon in our solar system with a dense atmosphere.
Thick and hazy, right. Gives it that orange color.
Exactly. It's mostly nitrogen like Earth's, but with methane and ethane creating this thick organic haze.
And the Huygens probe landed there.
Yes, part of the Cassini mission. Huygens parachuted down in 2005, a historic landing. It sent back images of a landscape that looked surprisingly familiar.
Familiar how?
It showed river channels, lake beds, shorelines, evidence of rain.
Rain. On Titan.
But not water rain, liquid methane and ethane rain. It has this whole methanological cycle, analogous to Earth's water cycle, lakes and seas of liquid hydrocarbons.
Incredible. A whole world running on methane. Any recent news from Titan?
Yes, quite a bit. Research in 2024 provided really strong evidence for a global ocean of liquid water beneath its icy crest.
A subsurface water ocean, like on Europa or Enceladus.
Potentially, yes, adding another layer of intrigue. And the James Webb Space Telescope observed Titan in 2023, spotting clouds and active weather patterns, confirming it's still a dynamically changing world.
So an active surface cycle and possibly a hidden ocean? Titan sounds amazing. What about Enceladus? You called it a superstar.
It really is, especially in the search for life beyond Earth. It's much smaller than Titan, an icy moon.
But something amazing is happening there.
Absolutely. Cassini made a revolutionary discovery back in 2005. Giant geysers erupting from cracks near its south pole. These cracks are called tiger stripes.
Geysers, like Old Faithful, but in space?
Sort of, but much bigger. Plumes of water vapor and tiny ice particles shooting hundreds of kilometers out into space.
Where's the water coming from?
That's the key. It's incredibly strong evidence for a large subsurface ocean of liquid water beneath the ice shell. And Cassini didn't just see the plumes, it flew through them multiple times.
It flew through the geysers.
It did. And its instruments detected water vapor, ice grains, salts, silica dust, and complex organic molecules.
Organic molecules, like the building blocks of life.
Exactly. Finding liquid water, energy sources, likely from tidal heating, and organic chemicals all in one place makes Enceladus arguably the most promising place in our solar system to search for present-day extraterrestrial life.
That is just astounding. And these jets, they contribute to the rings.
They do. They're the primary source for Saturn's faint, diffuse E-ring. They spew out about 150 kilograms of material every second. It's a continuous eruption feeding this huge ring structure.
Incredible. Just these two moons alone are worth the trip. Are there others that are particularly interesting?
Oh, definitely. You have Mimas, for example.
Mimas. Isn't that the Death Star moon?
That's the one. It has this enormous crater, Herschel, about 130 kilometers wide, which gives it that uncanny resemblance. It's mostly water ice, very low density. Yeah.
And Iapetus. I remember hearing about that one being weirdly two-toned.
Yes, the walnut moon. It has a very bright trailing hemisphere and a very dark leading hemisphere. Stark contrast.
Why is it like that?
The dark material is thought to be dust swept up from Phoebe, another one of Saturn's moons further out. As Iapetus orbits, its leading side collects this dark stuff. It also has this strange equatorial ridge, like a seam running around its middle.
And Phoebe itself?
Phoebe is interesting because it orbits backwards, retrograde, compared to most other moons. It's much darker and is likely a captured object from the Kuiper Belt, a visitor from the outer solar system that Saturn snagged long ago.
Wow, what a diverse collection of worlds. We've learned so much, haven't we? Mostly thanks to space missions?
Absolutely. Pioneer 11 and the Voyagers gave us our first close-up glimpses, But the Cassini-Huygens mission was the real game changer.
It orbited Saturn for 13 years, right? 2004 to 2017.
That's right. It completely revolutionized our understanding. Thousands upon thousands of images, incredible amounts of data on the atmosphere, the rings, Titan, and Enceladus. Just transformative.
And its ending was quite dramatic, too, the grand finale.
It was. To avoid any risk of contaminating potentially habitable moons like Enceladus or Titan with Earth microbes, the mission ended with a controlled plunge directly into Saturn's atmosphere. A noble sacrifice to protect these pristine worlds.
A fitting end to an incredible mission. But the exploration doesn't stop there, does it?
Not at all. Telescopes like Hubble and now the James Webb Space Telescope, JWST, are giving us new perspectives from afar.
JWST is looking at Saturn.
Yes, capturing stunning infrared details, studying atmospheric phenomena, and even providing data that suggests the rings might be, well, temporary on astronomical timescales.
Disappearing, really?
Slowly raining down onto the planet, maybe over hundreds of millions of years. Or perhaps evolving into new ring structures, or even small moons. The system is still dynamic.
So what's next? Are we going back?
Well, the journey of discovery is definitely far from over. There's huge interest in going back, especially to the moons. NASA's New Frontiers program is always considering missions.
Any specific concepts?
Dragonfly is a really exciting one that's been selected. It's a rotorcraft lander, basically a drone designed to fly around on Titan.
A drone on Titan?
Yes, to explore different locations, sample materials, and really assess its habitability. It's scheduled to launch later this decade. Missions to Enceladus to sample the plumes more thoroughly are also high on the wish list.
That sounds incredible. And understanding these things better might help with the ring paradox, too.
Hopefully, yes. Getting better measurements of ring mass, understanding the meteoroid flux more precisely. These will help constrain the models. And looking beyond our solar system.
To exoplanets.
Exactly. If we start finding ring systems around exoplanets, especially massive ones, it could tell us a lot about whether Saturn's magnificent rings are, a common occurrence or something truly special and maybe even rare in the galaxy.
So what does this all mean? It means the universe is just packed with wonders, constantly surprising us, constantly challenging what we think we know. Saturn, with its majestic rings, its bizarre weather, its potentially life-harboring moons, it's a reminder of the sheer beauty and complexity out there.
It truly is.
And maybe, just maybe, by studying these distant worlds, we learn more about our own place in the cosmos and the potential for life elsewhere. Until next time we meet in another episode of Tiny Talks Big Ideas podcast, stay safe, stay healthy, and stay curious.